Okay, so let's try do this in Eclipse. So I want to create a new class. I think it was my linked list. It implements list 211. I don't need a main, so finish. Have to make it generic. And then I want to fix the problem. Okay, so now I need to do the add. Actually, I need to create the things. So I need to have a private head private int size. Because again, we keep track of the size because we don't want to count every node when someone says how long is our list. We want to keep track of the size so we can return the size in a big O of 1 instead of big O of n. So now I need to create the linked node class. So I'm going to make it private because no one on the outside world needs to know what it looks like. Okay, and so it has what? What does a linked node have in it? You all watch my beautiful thing. Some people even found the errors in my code, in my spreadsheet. It has an E, often called data, to hold the item in this node. It holds the thing that's in the list. And it's type E. And we have a next. So what does next do? It points to the next thing in the list. So like if I'm the first thing, my next points to the second thing, and et cetera, et cetera. What happens if next points to nothing? That's the end of the list. There's no more. You've fallen off the end. There is no more. So what does head point to? The first node in my list. It's not the first item, it's the first node, because the first node holds that item, right? Head points to the first node if there is a first node, because there may not be a first node, right? If you have an empty list, I don't need a node to hold nothing. So talking about that, let's do the constructor. What do we want to do? We initialize it to null, saying that there is there's nothing in this list when we create a new one. Right? There's nothing there. It's empty. What's the size of an empty list? 0. Okay. And why are you not happy? Are you not happy? Okay. Did I mistype it? Don't like that. Okay, so what I needed to implement the add method, right? So I could again say add size E and be lazy. Perfectly wonderful. What's the big O of this add method? Big O of n, because I called the other method, this big O is n.
N squared?
It's not n squared because I just called 1. I didn't call this add in a loop.
N plus 1.
Well, it's n plus 1, but we don't care about any pluses or any constants in front of n. So like, we don't care that it's 2n. 2n is the same as n. For big O. You know, n over 2, big O of n over 2 is the same as big O of n. We actually don't even care if it's n over 1 billion. Because if n gets big enough, we don't care. Okay, so let's just comment that out. So let's do it the harder way. So there are two cases in this situation. One is we have some things in our list and we need to go to the end, or there's nothing in the list and we need to go to the end, but the end is head. So let's just sort of do both cases at the same time. You can put an if statement, but I'm not going to. Temp equals head. Okay, so I'm going to create a temp that is going to traverse down to the end of the list, and it's going to create a new node that's going to be added to the end. So the problem is I do need to update head if head is null. Because if I update temp, that does not change head. Head still points to null. So if there's an empty thing, so I want a linked node e node nide. Node. So now what do I have this new node. What do I need to do? I gotta set its data. And then I want to make sure that its next pointer is null. And in fact, I'm going to move this outside of my if statement. Because I know I need to create a new node for my thing. I've got to. So I could move that, and I can move this there, because I know that I will create a new node and I will stick it in the right place. So if there was nothing in the list, I create a new node and I point head at it. And what have I forgotten to do? Because I can do that outside the if statement also, because I'm always going to add one to the size. I'm going to add one more node to the list. So now, right? So if the head is not null, there is something there. So I need to go to the end of the list. Nope, sorry. Well, temp.next. I need to look at the next thing, because if temp is null, I fell off the end. I don't have it. I'm not attached anymore. So I need to point. I got to check to see the next thing is the end. So temp equals temp.next. So what is this doing? This is just leapfrogging over each node until the next one is empty, but I'm still pointing at the last one. When temp.next is null, temp is pointing at the last node in the list. So now that I've leapfrogged all the way to the end, I can say temp.next equals node. Do I need an E on this? the previous last one next was null. Now its last one now points to the new node, and the new node's next is null. Yes?
Can you not include the unequal to null in there? So, no.
Oh, you mean if you did temp.next? In Java, you have to have a Boolean inside your while loop. In C, if it's not 0, it's considered true. But in Java, you need a Boolean. And temp.next is not a Boolean, it's a linked node. So you have to have it in Java. Okay.
So for this, you're making a temporary link node, right?
Yeah. Essentially, it's a pointer to a linked node. Because in Java, all variables that point to instances of classes are references of pointers. Now, if it was an int, then it's not a pointer.
Okay. So after you go through this, what if the temp is like the pointer just disappeared?
What do you, oh, the pointer? Yes. I didn't create a new, how many objects did I create in this method? How many instances are created by this method? One. I called new once. So I created one new instance for this method. That's why I increment the size by 1. Now, the pointer or the next or temp can point, you can have multiple linked nodes point to the same instance. That doesn't create multiple instances, it just has multiple ways to refer to that thing. So my temp, I'm using just the leapfrog down the list of nodes.
This might be a little relevant. What if you didn't want to create a new pointer? If you want to make a copy of an object.
If you want to make a copy of an object, you actually have to create a new object and set all the values, all the member variables to be the same as the original object. If you want 2, right? You want a copy, you want a second one, you need to make 2. You need to make a new one. The only way I run out of space is if my laptop runs out of memory or my computer runs out of memory. There are no arrays. I can have as many of these, and I'm only creating, like when we were doing the array-based one, we doubled the size because we didn't want to keep doing that too often. In this case, we're only adding enough space to hold the new item.
So, because you're using pointers and pointer things, does this mean you could potentially have a bunch of lists that at the end end up pointing to another list? Or the same list, so it's kind of like
Well, wait till Wednesday. Well, I will talk about it, but I could point node.next and point to head, and it'll just be a big circle. But I still have head, which tells me where the beginning is, right? I still have a reference to the beginning. In fact, the homework assignment, I give you a head and a tail. I ask for a head and a tail, so you need to keep track of both the front and the back. But since it's circular, you actually only need one of the two. Right? Because if you keep track of tail, what's head? Head is tail.next. I can't with this link node because I only have a next, right? So how do I have no branching.
No, but you can have that next point to this node and then you've got
Oh, I can have a whole bunch of lists.
That same node, or
Like,
that same node.
does this work? I can have a whole bunch of lists. Right, there's my list. That's null. I can have a list A,
Yeah, exactly.
a list B,
Yeah, okay.
and a list C. But they're not really lists. These are linked nodes, right? So my list is defined by what head little different, right? I mean, yes, conceptually what I did is I've got head. This is my list. I created temp and then bounced it along the end until temp points to here. Right? Temp.next is null, so that I can set temp.next equals this new node that I constructed with data. Actually, and now when I say temp.next equals E, right? So if I was pointing it, if temp was at the end, I can't change this link node's next pointer because I am at there.
If it's something where it's linked to multiple different things.
I need multiple links. And in a couple of weeks, about 3, 4, 5 weeks, we get to trees. The tree structure looks very much like my linked node, except for it has a left and a right.
So the big O,
If that's a binary tree node, right? You could have non-binary trees that have multiple children.
so if you're big O, would that be like O into the end, or was that?
It's big O at the end because if I start at head and move temp, how many times do I have to move temp?
Oh, you just don't know what your, how many times you have to.
Well, I know it's size, right? Because size will tell me where it is. But even if I have size, can I get to this guy without looping over the list? I have to start at head because it's the only thing I know. I know the beginning, and I can say I'm going to do it size, actually size minus 1 times, because I want to stop right at the end. But linked lists, I can't get to any of these guys in the middle or the end without starting at head and going through. So the get method has a big O of n, because I got to start at head and go. What's the big O of get for an array list? 1. Look up the item in the ith place, right?
This is, so you sacrifice that because you're not wasting space.
This saves a little bit of space, or potentially a lot of space with all those empty things in the array. But I have linked nodes, not just E's, right? So there's a little bit extra space with the next pointer, and I have the E here, but I have a next pointer. So I'm using up a little more space. So if size equals data.length, this takes up more space. But size rarely is data.length because rarely is it the case where your array is absolutely full.
So if you're constantly getting really large and constantly shrinking down really tiny.
This is a better save, this will save space.
So it's all like a big space, so you shrink back down.
So this would be more complicated processing time intensive.
Depends on what you're doing with it, right? If you don't call get and set a lot, then it's okay. Because add and remove, what's the add big N, or big O? O of N. What's the add for this? Big O of N. There you got the same, if you're doing add and removes, these two data structures are basically the same performance. But if you're doing a lot of gets and sets, then the array list is a preferred one because it's faster. But it wastes space. It's a trade-off. Almost everything we do in computer science is a trade-off. Yes?
So if it's for like incrementing of the array list, you just made it +1 instead, wouldn't it?
But that operation, you have to copy all the items from the old array to the new array, so that's a big O of N. If you do it each time, then the add operation becomes a big O of N every time. Doesn't save you anything, right? By making that double in size and add, sometimes it's quick. And then every once in a while it's long, right? Yes? Sorry.
In the book, it says that it's return is true, but I'm just curious why you put them small.
I did not.
Oh,
Eclipse
Eclipse.
automatically, because it knows the return type is Boolean,
Oh,
it always chooses false.
oh, okay.
Eclipse, if it was an int, will always return 0. like I think I have it here. So this should be, you're correct, this should be true because I successfully added something to my list. And if you look down here, where's size? Size returns 0. Because Eclipse gave it to me for free, yay! But I didn't get to choose that. It automatically gives it to me. Just like the get or the set will return null, right? That's what Eclipse gives it to me so that my code compiles. So how would you, okay, yes?
So I'm only asking this because I had to do that on assignment 2, but like your add method, you're adding the data, right, to the array. Now if your data has like a member method, right, that changes that data, and then if you call that in the list instance of it, then your original data will change, right? So
Yes, you're asking a very philosophical question. What makes you you? Are you the same you from yesterday? Yes, I don't disagree, but you have changed since yesterday. You're still in this class, so you should still be in the member of the class, right? So you should be the same pointer, even though the thing can change. Now, we might say we want a different kind of data structure that takes originals that don't change, that are immutable. In that case, we would make copies of these things so that the person who had a pointer to it doesn't have the thing that I'm pointing to. Right?
But if you don't have any information because you're using something called the template version,
Right.
Then how can you make a copy?
I would there are ways to do it beyond the scope of this course. Java has the ability to inspect instances of classes to find out what all the methods are and what all the member variables are. You can actually access private things in Java using reflection. Don't worry about it at all. Java's not very secure that way. Yes?
I guess this is maybe more applicable to an array list, but when you do like a clone on that, and it just creates the whole, like this is kind of another array list, but it's all the same information stored in it. Is that kind of like why it's doing that? It's only creating a new array list of references that point to the exact same thing. So if you want like to actually clone it,
Yeah, there's the concept of deep copy versus shallow copy, right? So I could say, my thing points to the thing in it, or I create a copy of the thing in it, and I have to copy all of its member variables, right? I need to complete a completely new item versus just say, oh, these two things point to the same inner guts.
so I guess deep copy isn't the default
So,
behavior for that.
it's very expensive, and also deep copy can lead to some huge problems that if it points back to itself, when do you stop looping? Right? If I did a deep copy of that, how many nodes do you get? It should only be 5. But it may not know when to stop. And that's when, and again, Holbrook 3 is a circular linked list. Knowing when to stop is important. Just don't keep going while next is no. Right? Temp.next is not null is never going to stop. It will happily spin around the circular list forever. So what should it be if I'm doing a circular list?
Well, temp next is not head.
It's not head, because that means I'm at the end of the list, right? If temp.next is head, I'm at the end of the list in a circular list. If temp.next is null, I'm at the end in a non-circular list. Yes?
And if you wanted to actually move through
And that's what iterators do, and we're talking about that next week. And I did not give you the assignment I gave last semester, which is it's a very hard assignment where you have an iterator that goes through the list, removing items, move forward 3 items or move backwards 3 items and remove it. It's called the Josephus problem, where you need to remove people out of the, basically musical chairs. Theirs was a little nastier where they were killing themselves. But keeping track of that and doing it correctly is hard. Well, not everything changes, but now it's sort of like, where are you? What is the index of that item now? Is now different because some of them get shifted. Do I need to shift anything with a linked list? The pointer does all the shifting. I don't have to copy anything from anywhere to anywhere else. That's another beauty of the linked list. Remember the array list, if I had to add in there, I got to shift everybody out of the way and then put them in? I don't have to do that. I just change the next pointer. What else do I want to say? Oh! Go back to this. Just want to reiterate. Assignment 3. I want a doubly linked list. So now the linked nodes have a next and a previous. How do I do a bubble sort? You take 2 adjacent items and you decide whether or not you need to swap them, right? How do I evaluate that one and that one?
You have to compare the element within them.
Yes, it's C dot data compared to B dot data. Because the data in my example, you don't have to call it data, you can call it whatever you want inside the node. It's a member variable. But that's the thing we're holding. So instead of just saying array sub index and index plus 1, we now need to keep 2 of these pointers, and they got to be pointing at the right things, and they need to, depending on the algorithm, traverse down the list correctly. So it's tricky, but it's the same idea. So if I were to do a bubble sort, I would start as a do loop, right? How many passes do I need? And then size. So then I say I need something at this, and I have a left and a right. I might call it left and right. I don't know what I would call it, but left and right. And I got to make sure that the left pointer always stays 1 less than the right pointer. And I got to recognize when I get to the end, right? I don't want right to be pointing to head and left pointing to tail, right? So I then compare the values at L and R, and I switch them. Well, how do I switch the values? Why change the pointers? Why don't I just say E temp val equals L dot data. L dot data equals R dot data. R dot data. I just swapped those 2 values without mucking with the next and previous pointers. I don't need to muck with the pointers. If you muck with the pointers, you can do it that way. It just gets really, with a doubly linked list, you got to make sure that L dot next points to the right thing, right dot previous points to the right. I mean, it gets tricky. Because you got to muck with 1, 2, 3, 4, 5, 6 pointers if you swap those two things? Why not just swap the value stored inside the node?
Just call L dot next, R dot next.
Well, then I need to move it, right?
Yeah.
Then I got to move these guys over because I did my thing, right? So I just keep moving, just like in bubble sort, right? I just keep doing the left and rights until right gets to not necessarily the end. First time through, I need to get to the end. The next time, I need to go one last, and one last, and one last, and one last. That's bubble sort. Same thing with insertion sort. I keep track of where I am and shifting things, and then selection sort is a little different where I have to select the smallest and then the next one. You're doing the same algorithm, but instead of using arrays and indexes, you're using pointers. Little trickier, but not too difficult. So spend some time on this one. So sorts are not as easy as last time where you just cut and paste your array sort and change size, data.size to size, right? I mean, data.length, excuse me. Absolutely. Any questions?